then I can see my entire network. I can see any alarm for my entire network with my access. You can give that access to other people. You can say you can look at these 2 labs, you can only look at your lab, but you can basically see how everything is operating. And then you can give this to a quality control manager, and they can go ahead and they can really push just little bits of improvements and a little bit of percent differences in order to optimize the equipment in each lab, and so you get more fundamental improvement for everybody that is within your IVF laboratory. What is the system going to tell me? But what you really should be thinking is what is my environment? What is my facility? What is my equipment doing? That should be your first question, not what's the monitoring going to give me. You should really first ponder what is my equipment really doing and what are the parameters that you want to learn. And then you can go ahead and apply your sensors to that in order to better utilize the system. The fingerprints, those machine fingerprints or the equipment fingerprints, you need to start to learn how to cultivate and read what your incubators are telling you. Know that an incubator that is water jacketed for temperature has a very different fingerprint, as well as a very different way to calibrate than one that is heat done by electricity up through a heat plate. Those are ways to learn, and those are also ways to now address calibration. In the past, we used to track an incubator spot check twice a day or once a day, and if it wasn't right, we would check in the afternoon. And you would go 3 days, and if you felt that the spot checks that were happening basically at the same time every day, if they were off, you would go ahead and calibrate. Now, with those fingerprints that you're looking at, you can now make more educated decisions on if you need to calibrate or if you need to retire the machine and you're just not happy with it, with the way that it's performing to its neighbors. So here's some ideas of like those fingerprints. So here's some fun graphs that we can go ahead and look at. And fundamentally, this is the type of data that you start to get and that you need to start to write SOPs around. As we can see here, I believe that the one to the left is the door opening. So you can see what a recovery time is for a door opening. We utilize this information in order to then evaluate incubators. So in our lab network, we have incubators of all different types throughout the whole network. Thinking going to the future, you feel is the best incubator for a location. Maybe you don't buy their historic incubators, but now utilizing this information, such as a recovery time from a door opening. Maybe every incubator shows you something different, and now you have purchasing power in order to go in. This is a really good example of a fingerprint. So as you can see, there are lows and highs that go on. So if you look over to the left is an embryo lab VOC. You can see that it peaks and valleys all throughout the day, and then all of a sudden it quiets. And you can see the days that are on the bottom, and those probably a weekend, right? So that's probably a weekend when nobody is in, and the VOCs drop and they're more stable, and then it goes into those peaks and valleys. We can tell you that it wasn't until we did this VOC and basically looked at VOCs throughout all of the labs to realize that we have air systems that do things that you would never have known. We didn't know that in Austin at midnight every single night, the AC unit for the building turns itself off and has a standard reset inside of it. Our VOCs jumped through the roof and then took time to go ahead and autocorrect once that air system came back on. There was no way to know. It happens, I think, every night, like at 12:02 or something like that. And with that information, now we can go ahead and try to adjust. How do we want to do that?